and radius r is moved with a constant speed v by horizontal force F on a rough horizontal surface as shown. Find angle subtended by the base with horizontal during its motion. Now, till now, all the problems what we took, like it was there at rest, no? Look at this. This object is moving with a constant speed. Can we still apply the torque idea here? What is the basic definition of equilibrium? Net force, net torque should be zero. But they didn't say anything about the motion. But in all numericals, the body was at rest. See here, the body at rest or can move with uniform velocity or can rotate with uniform angular velocity. That is said to be equilibrium. So when a rigid body is in equilibrium, what conditions will arise? Net force zero, net torque zero. The body will have constant velocity, or the body will be at rest. The body can have constant angular velocity, or the body will be at rest. I just picked up a problem where the body is in motion and still equilibrium. It's the definition it says. Equilibrium doesn't mean that the body should be at rest. Okay, fine. This is what the question is here. Okay, now again getting into the mathematics. Whenever you get spherical object, it's quite very clear, no, how the normal contact force should act here. The normal contact force should act in such a way that it should be always directed towards the center of curvature. The diagram should be drawn, that should be oriented in that way. A little bit change, I'll make it. Some rough diagram. Get into show all the forces here. What direction the friction force will act. Shall we take friction towards left? Then only equilibrium is, then only, because it is moving with a constant speed v. You can show that velocity, or I'll just show that velocity here. The friction must act here. Then what about the weight? The weight should act through the center of mass. So where the center of mass for hemisphere will be 3r by 8. mg. So this is the center of mass. Then the normal contact should act in such a way that it should be along the common normal. So this is a normal contact. Find the angle subtended by the base with horizontal. So what is the basic equation like? F should be equal to mu n. It's a sliding friction which is acting. So F equal to mu n. Then applied force should be equal to the frictional force, no? Net force on the system along x-axis must be 0. Here also still I am writing few things better, I think. Let me come. So moving and you are writing net force because velocity is the velocity of the object is constant, no? So therefore F minus small f equal to 0. Keep it in equation 1. Then what is the friction? F should be equal to mu n. And what about n? N should be equal to mg along y-axis. Along y-axis, n minus mg equal to 0. So n equal to mg. Then for friction, F equal to mu n. Small f is equal to capital F. And this is mg. If, okay, there's a thing. So this is about the equation 2. This is about the equation 3. Okay, let's go for talk about which point, so that the problem will become very easy. I am making clear you can go for talk about any point, but always you pick up a point where The calculations will become very easy for you. Let me go for about A. Net torque about A must be 0. Then all will set up torque by mg. Do we know distance OC? If this is theta, this should be theta. And OB, so can we, I'll call this as point P. Look at the triangle you have. So what is OP should be r sine theta. No. So let's get into this one. So mg into this distance, how much it will be? P1, let me take this P2. mg into Cp2. This should be the anti-clockwise. Torque due to F and N will intersect actual torque due to applied force. Torque due to applied force will be F into perpendicular distance. What is the perpendicular distance? P1A or AP1. So what is CP2? OC is 3R by 8, no? So therefore sine theta equal to OC by, so sine theta equal to CP2 by OC. So we know CP2, substitute OC, and OC is what? 3R by 8. So that will get it. What about AP1? We don't know AP1. What is AO? AO should be equal to, this is the triangle P1, no? Yeah. AO should be R, no? Then AP1 should be what? Like AO minus OP1. So here AO AP1 should be equal to AO minus OP1. AO is R, OP1 is R sine theta. I'll substitute all this mg. CP2 is positive, so this will be F is equal to mu mg. AP1 is R minus R sine theta. Solve for theta, get the required answer. I'll have water.